And today I want to give a quick and pretty straightforward talk about what I think AI needs more of, and I'm going to introduce a little bit of technical talk in there because we are at MIT. And the thing about AI right now is we're working on capabilities, getting things bigger, more effective. I think we need to design privacy and auditability into that supply chain. And I want to tell you quite technically how we're going to do it. So the first thing, people have talked a lot about AI today. What is AI? We need to stop thinking of AI as some monolithic, large, singular magic model, and instead as a supply chain, starting from the way data is collected, all the way through pre-training and fine-tuning into how AI is served to us as an endpoint, and how we augment information that's going into it. All critical steps in how we actually deploy AI. And so, just to talk about a few examples of these to highlight the research going on at MIT, that's super exciting. We have a project thinking about this inference part. How do you actually get the AI model? We talk a lot about the model, but then are you running it on your GPU? Does anyone here have a H100 sitting in their back room? Like, it's a giant server. You're probably using an OpenAI endpoint or a third-party service, and it is very hard to know if these third-party services are authentically giving you the model they say they are. So ChatGPT, right when GPT-4 came out, it suddenly got worse. Performance went way down. What happened is they ran out of GPUs, and they started using smaller, more efficient models. They had these nicely distilled models, which slightly changed the performance characteristics. People complained about it. We had no idea what they had done behind the scenes. There was no way to know. So, importantly, some cool research coming here out of MIT, led by me, is work on verifying what AI model is actually used when you're served it at inference time, and guaranteeing the performance of the benchmarks that model is run on. This is a way that, to stop companies from lying or cheating you, you get cryptographic guarantees on how the model is performing in your use case. It's complicated zero-knowledge cryptography, but super simple to actually use and deploy. Turn to retrieval. I'm hoping someone today has talked about retrieval augmented generation, or RAG. This is the idea that you take an AI system, you query some external database, you pull in that real-time information to get a more relevant response. So maybe you're looking up a database for relevant facts. Maybe you're checking stock numbers on your AI that's helping with stock planning. Pulling from external databases. This is super exciting. It means you can have real-time relevant contextual AI, but it also runs the risk of leaking any usage of your AI model to third-party servers. And again, a piece of research here out of MIT is about building proper privacy in how we do retrieval augmented generation that has just been processed through ICML. Super exciting, deep cryptography work coming out of MIT that's immediately useful in how we're deploying these AI systems. So, those are just two examples. There's a whole supply chain of AI which needs privacy interventions, auditability interventions, which require technology, serious technology, for this to work. And we got invited by the president of MIT to work on a big impact paper bringing together all the cryptographers at MIT. MIT is famously a hotbed of cryptography. We invented most of it, all your encryption on the internet. A lot of it started here. And so we're getting the same group of professors and all of their PhD students together to write a big piece on end-to-end privacy in generative AI. Messaging, the web, HTTPS has all converged to end-to-end security. We care about it. We think it's about time that generative AI has the same end-to-end security that we expect everywhere else. And I'm super excited to do this write-up and share it with all of you. Thank you very much.